It's Miss Howell. We're going to talk about the heart and the blood vessels today. We talked last week about the actual blood components, and you did a little homework on that. And you watched a video last time from Khan Academy, and I'm actually going to have you watch 2 more from him this week to help you understand this particular unit. So let's get started. This time, because of the slides I chose, you're going to have to look for blue words instead of red. All right, so the human beings, unlike arthropods, have a closed circulatory system. What that means is that our blood is enclosed in a system that keeps the blood within blood vessels. Arthropods, and if you know what that is on your homework, write out a definition of arthropods and draw me a picture of one for extra credit on your next test. Arthropods, on the other hand, they don't have a closed circulatory system. They have an open system, and that just dumps blood directly from the blood vessels into the organs and tissues, and then they have to collect the blood and return it back to the heart. So, again, for extra credit on the next test, if you can define and draw me a picture of an arthropod and turn that in with your homework this week, that would be great. All right, so we have 3 main types of blood vessels in our bodies. We have arteries, capillaries, and veins. And then within arteries and veins are the smaller arteries, which we call arterioles, and the smaller veins, which we call venules. So arteries are thick-walled muscular tubes, and the main thing to remember is arteries carry blood away from the heart, and veins are thinner-walled with valves within those blood vessels. We'll talk about that in a few minutes. And they carry blood to the heart. And then capillaries are in between. They're tiny, thin-walled vessels that allow for the exchange of gases and nutrients between blood and cells. Capillaries are so tiny that the erythrocytes, or the RBCs, can only pass through them in a single file line. So you actually have 2 divisions to your circulatory system. And when you watch the Khan Academy video, you'll see that. So there's the pulmonary circulation. That sends blood to the lungs so that you can exchange your carbon dioxide and oxygen there in the lungs. And then you also return that blood back to the heart. So that's the pulmonary circulation. You also have your systemic circulation, and that is the circulation of blood throughout all the other tissues and organs of the body. Did you know that your blood really isn't blue? Most pictures and diagrams of the heart and blood vessels that you will see in textbooks and online use 2 colors, red and blue. Red is universally used to signify oxygenated blood, and blue is used to signify deoxygenated blood. But I just want you to know for sure that your blood is never really blue. So if somebody tries to tell you that, when you look at your wrist, some of you can see blood vessels in your inner arm or your wrist, and it looks like the blood is blue, that's actually the blood vessel walls and the fact that the skin doesn't transmit light rays very well through them. So it's kind of a distortion of the actual color of the blood. But if you've ever had your blood drawn, it comes out red. There's a slight difference in the red shade of the blood. So the more oxygenated blood, it's going to be a brighter red. And the more deoxygenated it is, it's a little darker shade. So it's a more ruddy red appearance. Your human heart has 4 chambers. There's 2 atria, and those are the parts of the heart that receive blood. And you have 2 ventricles, and those are the parts of your heart that push blood away. And when you watch those videos from Khan, you'll see that more clearly, and you can also read about that in the book. There's a handful of large veins that work to bring blood back to the heart. So you have some specific names you need to remember. You have the superior vena cava. Superior means top, so that's the blood returning from the upper portions of your body, so your arms and your head and neck. That's the superior vena cava. And then you have the inferior vena cava. Inferior means below. So that's the blood that returns to the heart from the lower parts of your body. So from the legs and your organs below the heart. That brings blood back up to the heart in the inferior vena cava. And then you also have pulmonary veins. Pulmonary veins, of which you have at least 2 left and 2 right, those bring blood back from the lungs back into the heart. And then, as we said, arteries push blood out away from the heart. So arteries, you have the pulmonary artery, which is moving the blood out of the heart into the lungs. And then you have your aorta. And the aorta branches from the top of the heart, and all the blood that must go to the rest of your body comes through the aorta. Okay, so again, you're going to watch 2 Khan Academy videos. I've put the links on your worksheet, and you'll use that to watch 2 short little videos, about 10 minutes apiece. And then the cardiac muscle. The organ of the heart is made of cardiac muscle. This muscle is striated and it's involuntary, so you don't have to think about your heart pumping. Cardiac muscle is also self-stimulatory, and all that means is because you're not thinking about it, it creates its own action potentials. So there's these special bundles of cardiac muscle tissue called nodal tissue, and you have 2 different nodes. You have the SA node, which is the sinoatrial node, and the atrium is at the upper part of the heart, and so the upper portion of the right atrium is the SA node, and that's a trigger that signals the atrium to kind of contract and push blood from the atrium into the ventricles. And then you have the AV node, which is the atrioventricle node, and that's called your pacemaker. And when you hear a heartbeat, that's because your AV node, the pacemaker, is causing your heart to contract. The cardiac cycle is divided into 2 phases. You have systole and diastole, or the systolic phase. That's the contraction of the ventricles that squeezes blood out of the heart and into the rest of your body. And then you have the diastolic phase, which is the relaxation of the ventricles, and it allows blood to fill the heart and fill the ventricles. These phases are measured when you have your blood pressure taken. And we're going to do that in class, and we'll talk about it further. I'll bring my blood pressure cuff and stethoscope so that we can do that in class. And the systolic phase is measured as the top number of your blood pressure cuff. And then the diastolic phase is the bottom number. So say your blood pressure is 120/70. So that's the amount of pressure or millimeters of mercury. 120 would be the systolic, and over 70, so 70 is the diastolic phase. We'll talk about that more in class. I'll explain it. And the sound that you hear when we listen through a stethoscope to the heartbeat, you hear a lub-dub, lub-dub, lub-dub. Well, that is an actual closing of the valves of the heart. So you can hear those flaps of muscle or those tissues flap closed as the heart is pumping and moving the blood around the different parts of the heart and out of the heart. And we'll talk about that again. So now we're going to look at how the heart pumps the blood through the body. So there's a pathway for circulation. So the heart squeezes and pumps the blood through the aorta. From the aorta, it moves to the arteries. At the end of the arteries, we have the arterioles, which are the smaller arteries. From there, it moves into the capillaries, which are the very thin-walled areas that actually touch the cells and the tissues of the body. And then we return the blood first with the venules, that's the tiny veins, and then the veins themselves, which pull blood back toward the heart, and the actual vena cava. Remember, we have the superior and inferior vena cava that dump the blood back into the heart. So as the blood reaches venules, see that pathway? The residual pressure that came from the first pump of the heart squeezing, well, that pressure is very low by the time the blood gets to the venules. So to help move the blood along, adjacent skeletal muscles have to squeeze the veins to help push blood back to the heart. So when you stand up to get the blood from your feet back to the heart, it's the calf muscles and the foot muscles and the leg muscles that help squeeze and push the heart or push the blood in those veins back up toward the heart. And then you have valves in your veins, little flaps of tissue, to prevent blood from falling behind or moving backwards. So that helps to keep blood from pooling in your ankles and feet because of gravity. So the valves in your veins help to put to their little flaps. We'll draw a picture and show that in class. And as you get older, those valves get weaker. So people in their later years have problems sometimes with blood pooling in their ankles and their feet. So think about it. Your whole circulatory system once you are an adult. So the average adult has 90,000 miles of blood vessels, including everything from the aorta all the way out to the capillary network, all the way back up to the vena cava and back into the heart. And all these vessels, the only purpose of these vessels is to carry life-giving blood that contains nutrients, oxygen, and carbon dioxide and waste throughout all the cells of the body. That's quite an amazing feat. Psalm 139:14 says, I will give thanks to you, for I am fearfully and wonderfully made. Wonderful are your works, and my soul knows it very well. You guys have a great week, and I will see you next time.